Okay, so we had found the zeros and x-intercepts, which were here. Okay. Remember this one had a multiplicity of 1, so it crossed, and this one had that multiplicity of 2, and that's why he just touched. Okay. And then I went back, remember, and I found that value here, and I found those two values down here. So, like, the -1 here gave us that -16, and the 4 gave us that 4. Okay, so now what I want, and we had just finished talking about the multiplicity. So I want to talk a little bit here about the turning points before we move on, before I give you the definition. Let's take a look at this one. Okay, so if we look at our original function, we had that degree of 2, right, which made that touch. And we had this degree of 1, which made that cross. And then remember I went back and I found those other points. Let's talk about, I want to talk about the turning points on this thing. Let's change color. I want to talk about the turning points. What do you think a turning point is on a polynomial? What do you think it is? When it changes, when it maybe goes from increasing to decreasing, or if it goes from decreasing to increasing. How many turning points do you think you see up here? You see 2. You see 1 right here, yes? And then you see 1 right here. Y'all agree? We good with that? Okay, so let's go back to the degree of our function over here. We had a degree of 3. Our degree of 3 gave us how many turning points? Gave us 2 turning points. This degree of 3 gave us 2 turning points. Okay? That will always be true. Your turning points will always be 1 degree less than your leading coefficient or leading term degree, your leading term. So if we were to multiply this out, we would find that our leading exponent had that degree of 3. So if you had known that before we graphed this, you guys would have known that you would have had a turning point up here somewhere. We didn't know exactly where, but we knew it was going to occur. And then we knew our second turning point was happening here because we knew that touch and had to kick back up. Okay? That's kind of a little preview of the turning point. The end behavior, next thing we're going to look at, if we look at this one, the end behavior is happening down here and up here. The end behavior means what? Where is it going? Where are the arrows taking our function? Where is this thing going? So if we're going this direction, if your x is going to positive infinity, where's the y going to? Where's he going to up here? He's also going to positive infinity. So that's what we call an end behavior. Let's go down here. And now, as our x is going down here to negative infinity, where's the y going? Y is also going to negative infinity, isn't he? Okay, so this one has end behavior where they actually match up, don't they? They both go to positive infinity and they both go to negative infinity at the same time. That's what we're talking about when we do end behavior. Okay, just a little a note here. This one, remember we said had a degree of 3. Okay, so it was positive. And we had 2 turning points. Okay, so degree of 3, remember that means we had something that was an x cubed, and it was positive. So let's take a look. All right, and so we saw an example of that in that last one that we sketched. All right, now let's move on to our, so the turning points, and I just talked about that. Your turning points, the number of turning points that you have will be one less than your lead term. Okay? It will be one less than the leading term. Now, I'm talking about after we've multiplied this thing out, right? That last one we looked at, it hadn't been multiplied out. We had that x minus 3 squared times that x, right? If we had gone ahead and multiplied that out and we had the actual polynomial like you guys kind of had on your homework. So if I had something like this, if I had 3x to the 4th plus 2x cubed minus x plus 1, for example, my leading term has a degree of what? 4. So if my leading term has a degree of 4, then how many turning points would we have? We would have 3. Okay, and that's all it is. Your end behavior, remember when we looked the other day when we first started with this, we looked at that power function. I want you to think of that as your leading, everything goes back to that leading term, okay? Your end behavior will depend on that very first leading term, okay? Okay, so we're going to start off where our exponent is even, and the slide I'm going to show you is going to show you what happens when your a is positive and when the a is negative. Okay, so let's look. Oops, sorry. Okay, here it is. So over here, as x goes to negative infinity, where is the y going? Positive infinity. So that's what that one's showing. And then over here, as x is going to the positive infinity, where is the y going? Positive infinity. So that's one of your end behaviors. And then over here, so we have the even exponent, but this time our term is a negative term. So that's all. What is it doing? It's just reflecting it, right? Instead of opening up, it's opening down, similar to a quadratic. So in this case, these are the two end behaviors. So in this case, as x is going to negative infinity, where is your y going? Negative infinity. And then over here, as your x is going to positive infinity, where's your y going? Negative infinity. Okay, so now, if your exponent is odd and your term is positive, here's our end behaviors here. As x is going to positive infinity here, where is your y going? It's going to positive infinity. And then over here, this one, as x is going to negative infinity, where is your y going? It's also going to negative. Those match up, don't they? And then if you're, again, your exponent is odd, but this time you have a negative term, here's your two end behaviors. Okay, up here, as x is going to negative infinity, where's your y going? He's going up to positive infinity. And then down here, as your x is going to positive infinity, where is your y going? It's going to negative infinity. So there's all four of your end behaviors. So what are our zeros on this one? 2x plus 1, what's that zero? Negative 0.5 or negative 1/2. Okay, and what's its multiplicity? 1. Okay, and this one, what's that zero? 3. and he's got a multiplicity of 2. So multiplicity of 1, that means what is the 0 doing? Touching or crossing? So this one's going to be crossing. And multiplicity of 2, what's this one going to do? Touch. Okay. We need the y-intercept. Remember, the y-intercept is when x equals 0. So let's put in a 0 for the x. So we would have 2 times 0 plus 1. And 0 minus 3 squared. So 2 times 0 plus 1 would just be 1. And 0 minus 3, so negative 3 squared would be 9. So that would just be 9. So we have our y-intercept at 0, 9. Okay. Turning points. We don't have this multiplied out, but we can see by our multiplicity. Here we have 2, and here we have 1. So this would be a degree of what? 3. You also know that you have a degree... No, scratch that. So how many turning points do you have? If you have a degree 3, we're going to have 2 turning points. Okay. So our end behavior, we have degree of 3, so our degree is odd, right? And our leading coefficient, can you tell if your leading coefficient is going to be positive or negative? It's going to be what? Positive. So for our end behavior, we're going to have a positive odd. Okay? So let's graph what we have. So here's our negative half over here, and then we have, what was the other one, 3? Okay. We know that the negative half, we know it's going to cross, right? So we're going to cross him. And we know that 3 is going to touch. Your y-intercept is at 9, so up here somewhere. So what are you going to have to do? You're going to have to go up here, touch that. I'm way too far out over here. And then we're going to do what? We're going to come back down. We're going to touch, right? That one just touches, and then he's going to bounce back up, right? And then he's going to bounce back up. Okay, does this match the end behavior? Go back and look. Does that match the end behavior of a positive odd? As your x is going to negative infinity, your y is going to negative infinity. And over here, as your x is going to positive infinity, is your y going to positive infinity. Does that match your end behavior? Yes. Do we have 2 turning points? Yes, we do. We have it right here, and we have it right here. Okay? So you just took all those things, all those concepts, and you graphed your first little polynomial. Any questions on that?